Linearization problem 1 focuses on a really interesting case, so I thought we'd do it first. But if you haven't seen the explainer video, if you don't understand what this means, please go back and watch that first. It's only a few minutes long. I'm putting it in the description as a link, so even the lazy monkeys out there, like myself, you still have an easy way to get there. Go watch it first. Okay, so I'm going to assume you understand what this means. And we're going to be looking for the linearization of f of x here, which is ln of 1 plus x, which means we're also going to need its derivative, f prime of x, which is 1 over 1 plus x. And now let's see what they say. Give the linear approximation at a equals 0, which is just a particular x value that we're going to stick in, right? And then they want us to find the window in which we can find values that are within 0.1. That's not as easy as it sounds, believe it or not. So let's play with this and see what we can do. Now, real fast, let me explain a little bit more. Natural log looks like this. All logarithms look like this. And somewhere along the way, remember natural log normally looks like this, but this is a 1 plus x, so it might be shifted left a little or something like that. It doesn't really matter. All we care about is that they're saying the natural log of 1 plus x is almost the same as just x, like y equals x, a straight line at a equals 0. So if I was to draw a picture of this, you'd see something like this. And this is like maybe where a equals 0. And they're saying this is so similar that we can say that they're pretty much the same. And they're asking what the window is that we can keep this true at, and they're not 0.1 apart from each other. That's the general idea here. It's just as though when I want to calculate pi and I know it's 3.1415629 and so forth, it takes a very busy compute algorithm. But if I just do 22 divided by 7, I'm going to get like 3.143. And if I only need a couple digits of accuracy, wouldn't it be better just to use this? If you're calculating pi 1,000,000 times a minute on a computer, just imagine if you only needed the first couple digits, how much memory space and compute power you would save doing something simpler. So this is actually a pretty important field of study. It's definitely part of computer science. Okay, with that said, how do I calculate this? Well, we know L equals f of a is just natural log of 1 plus x, and x for this is 0. Right? Well, it's 1 plus x. No, it's f of a. Yeah, it's 1 plus a. That's right, 1 plus 0 plus f prime of 0 times x minus 0. So I don't know if you know this, but natural log of 1 is nothing, so that's just out. And f prime of 0, so we put in 0 here. That's just 1 over 1, so this is just 1. So that's gone. And that's x minus 0, so you literally get L equals x. So it's not just that they're kind of the same. It's that they are the same. Now that's only true when x is equal to 0. After that, they spread apart. I hope that makes sense. So the second part they give you is find a ratio, like how close you can get. What's the window within a 0.1? And that is a little bit harder. That's a little bit harder because we have to say, okay, the difference between the natural log of 1 plus x and x is less than 0.1. And by the way, x cannot be less than -1 because you can't have the natural log of a negative number. And I thought about this. There is no algebraic way to solve this. You're going to have to actually plug in values to find this. And what I will say is we know that when x equals 0 is like in the middle. You know, it's that special point like right here. So there's going to be some kind of distance here, and it probably isn't the same. Where you got to plug in values, I would plug in negative 0.5 and positive 0.5 and see what I get. And if it's no good or positive, then I'd move closer or farther away depending on the answer. So you literally have to do a classic plug and play. There's no algebraic answer for this. I've tried using e to the something. I've tried rearranging and using different variables. I can't find a way through it. But what I did find as I was plugging things in is that I got negative 0.38 and I got like 0.52. And I think the point for this is to say, look, these aren't going to be the same distance apart from each other. They really aren't. Even when x obviously was 0 in the middle. And you're going to actually have to plug in values. There's no algebraic answer. I find that fascinating. So it was something like x equals 0.52 here, and x equals negative 0.38 here. So where x was 0, this distance was not the same. And I just want to highlight that with problem number 1 as we actually worked out the linearization and the approximation for it here.